Alright, in this video we are looking at pulling out common factors. So the sorts of year level you might be needing this is year 12, particularly when you are differentiating. Alright, let's have a look at a very basic one first of all. When you're presented with a term that, or an expression, sorry, that has two terms in it, and both the terms are multiplied by a common factor. We can see that 2 is multiplied by x plus 1. And minus a is also multiplied by x plus 1. That means we can put the 2 and the minus a together and say, well, 2 and minus a are both multiplied by x plus 1. Now that is fully factorised. Let's have a look at some other examples. This one you might use if you're using the chain rule. So you're often left with high factors. High powers here, and we can see that both terms within the brackets have an x. If we ignore the power 4 for a moment and just assume it's to the power 1, we can see that x is a common factor and we can pull that out. But because it's to the power 4, we'd actually be pulling out x to the power 4. And here's why. Let's write out this, and this is tedious, but if I write out pulling an x out 4 times, so it's all multiplied together, you can see that once we simplify it, you can see that, oh, I'm going to come off the page there. How do I, okay, I've sorted it, plus 5. Now you can see here that I've got, by pulling out what looks like a single power of x, because it's to the power 4, I've had to pull it out 4 times. Now if we simplify that, we've actually got x to the power 4 and then 2x plus 5. And that's now fully factorised. Okay, let's look at an example where you may be using the chain rule, for example. If you've used the chain rule, we're often left, once we've done the correct derivatives, with long expressions like this. And what we have to recognise is, well, are there any common factors that we can pull out? And what's the highest common factor we can pull out? Looking at this term, we can see there's an x squared here and an x plus 1. Look at this term here, there's also an x squared there and an x plus 1. That's the highest common factor between both the terms that I can pull out. So let's pull out the x squared and the x plus 1. And then I'm going to introduce a square bracket. Okay, so this just tells me that it will need simplifying afterwards. So let's look at the first term. In order to get the 3x squared bracket x plus 1 squared, I need an extra 3 and an extra x plus 1. Now let's look at the second term. I've got a 2, so it's a plus 2. X squared I've pulled out, so I've still got an x. And that's it, because I've also pulled out the x plus 1. Now let's just focus on that square bracket. We can simplify that squared bracket now. Let's have a look what we've got. We've got 3x plus 3, so I'll keep the squared bracket for a moment, plus the 2x. And now, finally, I can now change it to a round bracket because it will be fully simplified to become 5x plus 3. Okay, now that's fully factorised. And one more example like that, which again you might use again with the product rule. So let's do a similar one, 6x squared bracket x squared plus 1 all squared plus x squared plus 1 cubed. Now look at both the terms. You've got two terms, one here, one here. Both terms have an x squared plus 1 squared within each term. So that's going to be the common factor that I'll pull out. And then I'll introduce the square bracket. So this term needs an extra 6x squared plus, and this term needs an extra x squared plus 1. And again, let's just simplify those brackets. Let's do the squared bracket first. So we've got 6x squared plus x squared plus 1. Now I can convert them to round brackets because it's easy to pull the like terms together. I've got 7x squared plus 1. And that's now fully factorised.